Okay, all right. Hi, everybody. Thanks for tuning in. Just so you know, this is a re-recording of a presentation from the MASERC Showcase in September. We're re-recording it because we had some technical challenges, so wanted to give Dr. Levers a chance to give the full talk again. My name is Meg Dorer. I'm on the MASERC staff here, and so we'll go through the talk, and then I noted the questions that were asked from the audience back in September, and I'll be just repeating those questions so folks can hear what the feedback was. And with that, I'll introduce Dr. Levers. Dr. Lucy Levers is a research associate at the Water Resources Center at the University of Minnesota Twin Cities. She earned her PhD and master's degree in environmental sciences from the University of California, Riverside, and studied human biology as an undergrad at Stanford University. Her current research emphasizes interdisciplinary projects in natural resources, ecology, environmental economics, and social science. So with that, I will turn it over to you, Lucy.
Thanks, Meg. Thanks for that introduction. So this project is part of a larger project on public values of invasive species management. This is specific to interactions between phosphorus and carp management. And this is actually part of Dr. Amit Pradhananga, who's my compatriot, and our graduate student, Casey Runquist. So this is part of her thesis work. So a little bit of background on this whole body of work. We know that aquatic invasive species management can restore ecosystem services, but we don't really know a whole lot about the benefits of doing so, particularly in monetary form. And we also don't really know a lot about how people think about AIS and how that kind of impacts what management and behavior decisions that they kind of make. So the overall project goal here is to quantify and analyze the ecological, social, and economic value of aquatic invasive species damages and management as they relate to ecosystem services. There's multiple components, including some survey work, but this particular project is on watershed manager interviews, specifically about carp management that they've conducted over the past 20 years. So just a little bit of background. I'm sure a lot of you are familiar with the common carp. This is an invasive species. It's very widespread in North America. It causes a lot of ecosystem disturbances, which particularly has impacts for native species and native waterfowl is of particular note. The interaction that we're looking at here has to do with the phosphorus cycle. So carp, we believe, have impacts in terms of the phosphorus levels in lakes. So carp are bottom feeders, so they hang out in the bottom of lakes. And there's two kind of mechanisms through which we think that they can impact phosphorus. One is by increasing internal loading in the lake by kind of rooting around the soils at the bottom of a lake, which kicks up phosphorus that's in those soils. And the other is potentially through their digestive tract. So they're large creatures, they consume food and they excrete. And then also potentially they can die and increase phosphorus in that way, because they can have some pretty substantial biomass in lakes that they're infesting. They're very widespread in Minnesota, particularly in central and southern Minnesota. There's quite a few lakes that have pretty decent carp populations. So carp management can be through a number of different forms. Everything from drawdown, which is basically where the lake is drained, to get rid of them. They can be netted. They can be poisoned with poisoned corn, essentially rotenone. So there's a lot of different methods that we use to kind of get rid of some of these suckers. And part of this project was trying to figure out what's kind of the most common management strategy and how well it works, and also how much it costs. But the main point I'm trying to make today is the work that we've done on this so far about whether carp management has an impact on lake phosphorus. So we're trying to figure out is if we manage the carp, are we also managing phosphorus? Do we get a bang for our buck by actually managing those two different components? So we want to know if there's any evidence that carp reduction is correlated with phosphorus reduction. And that's really what we're testing in this project. Carp reduction correlated with phosphorus reduction. And we also want to know eventually is what can we learn from modeling lake phosphorus with carp as a factor. So essentially that picture I just showed of the phosphorus cycle with the little carps at the bottom, like what happens when we add carp into the phosphorus cycle? What does that do to the whole system? So what did we do actually? Okay, we collected a lot of data, over 90 lakes, 12 different Minnesota counties. We did this over the past year. Contacted water management organizations and watershed districts, basically anybody that was managing carp for lakes. And we also collected data again on what carp management they'd done, how much they cost. Now, because we're asking that very specific question about whether carp reduction is correlated with phosphorus reduction, we didn't, for this presentation, we're not including data from all 90 of those lakes because we wanted a very specific subset, and that was we wanted lakes that had very high carp, above 100 kilograms a hectare, which is kind of the cutoff point for carp damages before management. And then we wanted management that actually worked. So we wanted a management strategy that reduced it to below 100 kilograms per hectare afterwards, so that then we could compare the phosphorus levels before and after the management had occurred. So the lakes that we included were mainly in the Twin Cities area, but also down in Freeborn County. The one in Freeborn County is Pickerel. And then the ones in the Twin Cities, I'll blow that up a little bit. Here's a picture of the watershed districts and watershed management organizations. There were quite a few in Ramsey, Washington. It was Casey, Coleman, and Keller. And then there were quite a few in Riley, Purgatory Bluff Creek, which is Staring, Susan, Lucy, best lake ever, Lotus, and Gervais. That might be Gervais. I'm not sure. I apologize for that. I've only ever seen it in writing. And then we also have, oops, I'm sorry. We also have one up in Rice Creek. Okay, so the questionnaire that we sent out to the watershed districts, they looked over the past 20 years of carp management. And as I mentioned previously, there's a bunch of different methods here that came up. The rote known, also physical barriers, box knitting, stocking, commercial seining, and then drawdown. We also collected biomass data, and again, it was important because we needed that data in order to include them in this particular study. And then the management costs, and also phosphorus management, so that they've actually engaged in any particular phosphorus management at the lakes. Generally speaking, they do not. Most of the phosphorus management, because agriculture is such a big component of phosphorus pollution, occur in the greater watershed, things like cover crops and barriers and buffers and stuff like that occurs on the field. So most of these watershed districts didn't really do any direct phosphorus management. We also collected additional data. Most important would be the lake total phosphorus data, which had from a number of different sources. We also have climate data. We have information from the TMDL reports. And then we used a lot of really lake-specific information from experts in the field. And this was because we wanted to make sure that we were not missing anything that would be super obvious. Someone's got some wastewater treatment plant right next to it that's dumping a bunch of phosphorus in the lake, or who knows, that type of thing. Okay, so this is our data. So the green bars here are the total phosphorus before, and the yellow bars are total phosphorus afterwards. So when we say total phosphorus before, what we're doing is finding the average of summertime phosphorus levels taken in that lake before carp management happened. And those can be from a few different sources, but essentially we found a monthly value for each of the summer months, and then we averaged them together for all those years that occurred before carp management. And the gold bars, same thing, it's just occurring after the carp management. And then the gray dots are the biomass values before, which are all over 100 kilograms per hectare. That the biomass data is on the right x-axis there. And the blue dots are the biomass levels after. So these are arranged in terms of lake shallowness. So you can see that a particularly shallow lake probably has a bit of an impact over some deeper lakes. And we definitely think that that is a key here, is that a shallower lake, this is a little bit more effective. And it kind of makes sense, since carp, as I said, they tend to be in the benthic zones of the lakes. So a shallow lake that's like sort of a larger proportion of the lake overall. And you can see some pretty significant appearing movements here. So for instance, in Casey and Pickerel, the biomass goes down quite a bit. So does phosphorus levels. Also in Staring, you can see it looks pretty significant there, that it's going down pretty substantially. And you can see that the lakes that have higher phosphorus levels initially seem to be the ones that have like more significant biomass decreases, whereas the ones like, say, Jervay, that are pretty, the phosphorus levels are pretty low to begin with, perhaps that don't have the same impact. So I'm going to show you the same chart, but just in table form here. So again, these are the exact same lakes, and they're listed again, the same thing. So they go from shallowest to deepest, Casey being the shallowest, Riley being the deepest. And so the percent change right there, okay. So that is the percent change from the total phosphorus before to the total phosphorus after. So you can see that first one, Casey, it's a 60% drop. So it's a really big drop, and it's significant. So the little red bolts are significant at the 95% level. So the significant ones are those ones I pointed out that, I'm going to go back to this one just a sec. So you can kind of see the ones that look pretty obvious, like there's a big difference between phosphorus before and after, which is like Casey, Pickerel, Staring. Those are the ones that pop up as being the most significant. The other thing I want to point out here is not only you can see just kind of in general that, okay, the shallower lakes, the very shallow lakes seem to be have the most reduction, especially compared to the more deep lakes. But also note that the treatments are a little bit different. So we have drawdown happening in Casey. So one thing with drawdown is it's possible that, you know, by drawing down the lake, you're also removing a bunch of phosphorus. So that could not only be removing carp, but removing phosphorus that's within the lake as well. So there can be a physical phosphorus reduction happening there that's not just because the carp are being removed. Whereas with Pickerel and Howard, you have rotenone and the electric barrier. And then Staring is the only one that we have with commercial staining, that showed a significant difference. Staring is the kind of in the middle of the depths. But you can see that its phosphorus level is quite high initially relative to the other lakes. So we think that there's something going on, like a connection between the initial phosphorus level and the depth of the lake and the carp removal method that's occurring that are causing some of these results. Again, these are the ones that are significant. So does carp management have an impact on lake phosphorus? Yeah, I mean, you know, we definitely think there's some evidence here that carp reduction is correlated with phosphorus reduction. As I mentioned, there's other factors going on, and it's quite possible that there's only certain lakes that this would maybe be effective in, particularly maybe a shallow lake, lakes that have fairly significant phosphorus while the carp is there, And it may only be occurring to with certain types of carp management. So the next step in this is that we really want to see what we can possibly learn from modeling lake phosphorus with carp as a factor. So we're continuing this project by looking at some of the literature values that have to do with how much phosphorus carp can actually remove sort of per kilogram, and combining that with some of our accounting or economic data that we've collected to try and look at, okay, what's sort of the cost benefit of doing this, like of using carp management, not only to manage carp, but also to manage phosphorus. So thank you very much. And I think we've got a few questions.
Thank you, Lucy. That was great. Let me pull up the questions from before. Okay. Okay. Can you talk about the methods that researchers use to measure the biomass of carp, and why would this method, why would biomass be chosen as a metric over counts of individuals?
Oh yeah, that's a great point. So really what they're doing is they do sampling. So they'll sample a certain section of the lake and then pull all the carp up and weigh them. And the reason they do that is just because these carp grow very large and they grow relatively quickly. But if you were to count them, you might end up with like a whole bunch of little teeny tiny carp, and then or maybe like one or two giant carp. So like two little teeny tiny carp aren't going to have the same impact because they really are sort of ecosystem engineers, people like to call them, because they really root around and mess up the bottom benthic areas of the lakes. So the size of a carp is really kind of important. And it turns out that it makes just as much sense scientifically to just say, all right, let's just use the mass. We won't even bother talking about counting them, because essentially 2 10-pound carp are going to have the same impact as one 20-pound carp. Plus, it's just so much easier and less time consuming. You know, you can just throw them all together and weigh them instead of sitting there trying to pull them out and count them. And if you were to count them, you'd have to weigh them anyway, because again, you need to know how big these things are to figure out the impact. And that's been shown in a lot of the literature, including that's why we picked that 100 kilogram per hectare value. It's been shown that we can just use numbers like that. But yeah, thanks for pointing that out. That was it is a little weird when you first look at it, certainly.
Yeah, no, that's a great explanation. The next question is about how your study did or didn't incorporate untreated control sites into looking at the monitoring, And the person asked, is it possible that phosphorus in some lakes would have decreased on its own in the absence of carp management? And was your research able to capture this?
That is a really great question. So because we were really specifically trying to see if carp management had an impact, was why we chose lakes that we knew had a lot of carp in it, which were then managed and then had lower carp, because we weren't so much testing whether a carp management strategy was effective. We wanted to see if the carp themselves had an impact on the lake. So what we would have needed to do, which would have been great, would have been, okay, well, let's look at a bunch of similar lakes that have really high carp levels but were not managed, and see if their phosphorus level remained the same. And if they're in the same watershed, that would have been ideal. But we didn't have those lakes, so we weren't able to do that. But yeah, that's certainly a really good point. And that's kind of the problem with some of these, you know, real life data collection, is that we don't always have those examples that we would like for sort of a perfect experimental design. So yeah, unfortunately, that's kind of an issue. And again, like I'd mentioned earlier with the drawdown, that's a bit of an issue as well, because we don't really know. It's impossible for us to say, oh, if you do drawdown, how much of the phosphorus came from removing the water and how much of it came from removing the carp. It's a little bit hard for us to make that point. But luckily, we have so many lakes that we can show that overall there are some there are some directions that the data is going, which is evidence in and of itself. But yeah, that is a really good point. But if anyone knows of any lakes that have all those characteristics, I'd be more than happy to include them.
This kind of makes me think of something that Shemek Bejer had mentioned, that in some lakes where you're doing large scale carp removal, the literal phosphorus in carp bones is you're doing kind of a direct removal, and that in really lakes with really severe infestations, that's a measurable phosphorus reduction, just the actual removal. So it's
yeah, that's interesting, Meg, because that's one thing that with this, we have a new project that we're working on, which is a database project. And one of the initial goals is starting some of that modeling that I talked about, to actually look at sort of these input-output analyses and actually kind of just crunch the numbers, like how much phosphorus is in a carp, like, so that we can kind of start answering some of those questions. Because yeah, you're right.
Yeah, it's really interesting.
Huge, right? I mean, 100 kilograms a hectare, like that's a lot of fish.
Yes, it is. And I think those figures can feel really abstract to folks, but so anybody watching this, I recommend you go look on YouTube, some of the MACER videos about carp removal or carp solutions, and you can kind of get a visual sense of what some of these numbers, when we say 200, 400 kilograms of carp per hectare, what kind of fish density that actually translates into, and it's a lot.
Mm-hmm.
Okay, the next question. So you did talk about lake depth a bit. There's a follow-up question here. Can you just talk a little bit about why lake depth is such an important factor? And is this related to the importance of aquatic plant communities in shallow lakes?
Oh yeah, that's a good question. So one of the reasons that I think the shallowness is really important here is just because of mixing factors. So when you have the more shallow a lake is, the more fully mixed it is. So the circulation you can think of within the lake is occurring at a more efficient rate than, say, in like a super deep lake that's going to have like super stratified layers. So carp, like all animals, kind of exist in a particular niche, and they hang out at the bottom of these lakes. So a shallow lake, you can kind of think of it like they have a higher percentage, if you will, of the depth of the lake that's like suitable for them to live in. Whereas a super deep lake, they're having a smaller percent of the lake. So they have like a smaller sort of overall impact. Can you repeat the one about the plants? I lost it in my mind while I was talking about.
Yeah, no, it's okay. Well, they're talking about how depth impacts the the bang for your buck on carp management. If that is the outcomes of carp management, if that's related to like how important aquatic plant communities are in shallow lakes versus a deep lake.
Oh, right, yeah. So it's kind of a similar idea, right? So depending on what type of native plants you have, in a shallow lake, again, because the carp can kind of take over more easily, they could potentially have a bigger impact on those plant communities. Whereas if you have a deep lake that has different plant communities that are occurring at different levels in the strata, then you might have a bunch of native plants that aren't really so impacted by the carp that are like way far down. Whereas that's not really going to be the case in a shallow lake. I mean, you can kind of think of it like if you have a roommate you don't like in a studio versus a roommate you don't like in a 5-bedroom house, right? It's a lot easier to get rid of.
That's a very good analogy. I like that. Yes. Someone was wondering when this work is going to be completed and published, and where it might be published to.
Yeah, thank you. That's a great question. So this is the bulk of Casey Runquist, that's our graduate student, her thesis work. And if any of you watching are in Minnesota and in need of a talented and hardworking invasive species expert, she's going to be looking for a job pretty soon. So she should be graduating this year. So we're excited about that. So she needs to complete her thesis before we can publish off of it. But I suspect that we'll be submitting this for publication in a formal sense in the spring. And there certainly will be available in the thesis form, which will be published at the university sooner than that. And there's probably some outlets for reports and things like that for MASERC also. And of course, this presentation is available. And anyone that has any particular questions about anything, you know, please email me and we can work on getting you that information.
Hopefully anybody watching this, if you want to get in touch with Lucy or Amit, you can see their emails down at the bottom right of the screen there. Getting almost to the end here. What was the source of the water quality data that you referenced?
The water quality data, the phosphorus data, that was kind of interesting. So some of that was from EQUIS and some of it was from the watersheds themselves, which some of it kind of overlapped. And DNR also takes phosphorus data. So we kind of collected quite a bit because we really wanted to get as much data before and after the CARP management had occurred. So it's not all from the exact source. I think I have a list here. Yeah. Oh yeah, the Met Council too, yeah. So a few different sources. But yeah, so we thank everyone that's out there taking lake phosphorus data because we're using it.
Oh, that's great. Okay, well, one more question. Will this study or future directions in this work be looking at changes in other parameters such as clarity, chlorophyll A, and changes to the plant community?
Oh, well, thank you so much for asking that question. So yeah, that's my kind of ultimate goal, which is why we were collecting so much additional data as well, like the climate data and the data from the TMDL reports. So at the Water Resources Center, we have a sort of a spatial database, the Lake Browser, that includes a lot of satellite generated information about lakes, including chlorophyll. My hope is that we'll be able to have a system where we can have all of this data kind of together. So we'll be able to do some like really cool spatial correlations and regression analyses to try and look at not just invasive species infestations, but also the managements that have been occurring over time to see what kind of impact they've really been having, so that in the future, when people are trying to decide what's the best management choice to make, they'll have a little bit more evidence to kind of back up their decision with. So yeah, thanks for asking. That was a plug for my next project. So
Awesome.
That.
Cool. Well, that's all the questions there were.
Cool.
So thank you very much, Lucy, for redoing your talk with us, and to
thank
anybody
you for letting me. I had a
tuning in.
Catastrophe last time.
Yeah, to anybody tuning in, thanks for watching the talk, and hope to see you at next year's showcase.